Hello everyone, this is Venkat sir. Okay, today we are going to discuss topic is projectile motion. Okay, projectile motion. So here also we have different types of projectile motion. That is a horizontal projection, okay, and oblique projection, and from the inclined plane, inclined projection. So we have different projections are there. So today we are going to discuss projectile. That is the first one, oblique projectile. Okay, so first we can discuss what is the definition of projectile. Okay, general idea I will give first thing. Suppose if you are playing the cricket, okay, so when you are playing the cricket, suppose the batsman is hitting the ball like a six, assume six, okay. Suppose the ball is when the batsman hitting the ball is moving in this path, okay. So based on his how much he is applying the force, and at the same time with the how much inclined angle with the horizontal, like based on that one the ball is projected, okay, and reaching the different places. And when we are seeing the cricket matches, we can observe sometimes they will show that there's a height and a range. Okay, there's a maximum range is a 90 meter, 92 meter, height is a 21 meter, like that they will show. So how we can calculate this height and range, okay, that we can discuss in this topic. Okay, I hope understood. So now, so generally we can give the definition of projectile. Okay, so there's a projectile when you are throwing the ball or any object, okay, with a other than 90 degrees, means either 0, not equal to 0, and not equal to 90 degrees, means with a horizontal certain angle we need to project the object. Okay, that projectile, that path is called what we can say, path of the projectile, that is called we can say trajectory. Okay, so now we can see here the example I'm giving here. Okay, say one body I'm taking the from this point, we can take the horizontal point, and this point is called we can say projection point. Okay, with the some velocity I projected. Okay, that velocity we can take the u. That is initial velocity. Projection velocity is u. Okay, so now when I am projecting the ball, this is c with the horizontal angle is how much theta degrees, means other than the 90 degrees or 0 degrees. Okay, so then it is projected this object, it reaches a certain height, and after that again this object is coming towards the ground due to the gravity. Okay, so at the maximum height what will happen? Okay, we can discuss one by one. Okay, so now this a projectile means any body projected into the air with a velocity at an angle other than the 90 degrees, okay, with the horizontal is called what we can say oblique projectile, right? Now initial velocity is u, and if they are making with the angle with the horizontal is theta, assume this is x-axis and this is a y-axis. Generally this x-axis we can call horizontal projection and y is a vertical projection. Okay, so now, okay, so we know the kinematic equation. Already you all learn in motion and gravity. So in motion and gravity, we can discuss a body moving vertical upward direction. We can take the gravity is minus g. Gravity acceleration due to gravity we can take minus g. Okay, and in the when the body is projected reaches the maximum height, the final velocity will become zero. Here need to remember the one point, this is the final velocity means in a two-dimensional motion vertical component velocity will be zero, horizontal component is not equal to zero, it will be constant at the maximum height. Okay, that point we can discuss. Okay, right. So now with when the body is projected vertical upward direction with with angle theta, so this velocity can be divided into two components, means resolved into two components. Okay, we can divide this u in terms of along the horizontal component, along the vertical component. Okay, this is u cos u can be divided into two components, u cos theta and u sin theta at a projection point, means initial point. Okay, but when the body is moving in a projectile path, so here every instant time the velocity will be changed. Which velocity will be changed means here horizontal component velocity it will be constant, but vertical component velocity will be changes. How we can change it? That is a u sine theta minus gt. So we know very well from the kinematic first equation, v equal to u plus gt. Okay, vertical upward direction v equal to u minus gt. Why? Because when the body is moving, vertical upward direction gravity will be decrease, right? That's why we can represent u minus gt. So here the value will be slowly u minus gt means this term is increasing, and what will happen? The velocity will become at a point at any instant time it will become zero. So mean this a vertical component velocity will become zero at a which point? Maximum height. So means when the body is moving from projection point to maximum height, velocity will be decrease. Vertical component velocity will be decrease, but horizontal component velocity will be same. Okay, and at a maximum height, Vy equal to 0. But here you can see the horizontal component velocity is same. It does not change. Okay, every instant time you can take here u cos theta, but vertical component due to the gravity, what we will get here? V equal to u sin theta plus gt. See, and the body is moving from maximum height to reaching the ground, striking the ground. Velocity is increased. Okay. So projection point to maximum height, velocity will be decreased. And from maximum height to striking the ground, vertical component velocity will be increased. Okay. So where the final velocity will become zero. Okay. That height is called what we can say maximum height. What is that? Maximum height, right? So this is the we can do the components we written. Now step by step we can discuss the every instant time what is the magnitude of velocity and what is the direction of velocity, and we can find the trajectory of the this is a projectile we can find. Okay, one by one we can discuss. Okay, chalo. Right. So here from this equation I'm writing the some words here. Horizontal velocity ux equal to, I'm writing u cos theta. Same thing, vertical velocity, vertical velocity uy equal to u sin theta, right? Okay, so you can see here at any instant time, what is the velocity vector? What is the velocity vector initial at any instant time? Velocity we can write u equal to, okay, that we can write v equal to square root of at any instant time taking we are initial velocity u, at any instant time we can take horizontal component velocity square plus vertical component velocity. So we know already it is a projection is there, it is dividing into two components, resolve into two components, right? So we can substitute here in this equation. So just now we discussed horizontal component every instant time it will be constant, that we can write u cos theta whole square plus at instant time what is the velocity? U sin theta minus gt. Clear? So this is the uh, at any instant time velocity. Okay. So same thing at any instant time, if you find the direction, then what we can write as no, we are finding this unit vector. This is a initial vector at an instant time we are finding means we can take the perpendicular component by base component. That is, we can write tan theta direction tan theta equal to vy by vx means vertical component velocity by horizontal component velocity. U sin theta minus gt by u cos theta. What is this one? Direction of vector. Okay. So this is a basic thing we can discuss the velocity of a vector. Now, so we can find the displacement vector. What is the displacement vector? What is the displacement vector? Right. So here displacement vector means it is divided into two components. So I'm writing here displacement vector is s bar equal to, I'm writing the two components divided xi plus yj. Okay, so means here the two components are there, horizontal component and vertical component. Okay, we can find two components, horizontal and vertical component. Okay, so how we can find the vertical and horizontal component? So by using the kinematic equations, right? So a displacement vector need to find by using which equation we can find? Kinematic second equation, right? S equal to ut plus half gt square. Okay, so this way we can find this a horizontal component along the x-axis we can take. Okay, along the x-axis. So we can represent along the x-axis. Now one more point we need to remember here, gravity is how much beta? Gravity, horizontal component gravity ax equal to g equal to 0. Okay, why you can observe here horizontal component velocity u cos theta, u cos theta, u cos theta every instant time. Means final velocity u cos theta, initial velocity u cos theta. Means acceleration equal to u cos theta minus u cos theta by time. What will get? 0 only. So horizontal component acceleration will be 0. Means g is a 0. Okay. Then from this equation we can write Sx equal to u into what we can write here? U, this is a horizontal component, ux into t. So this is the equation. So then here horizontal component velocity what here? Horizontal component you can see here ux equal to cos theta. Okay. Then horizontal distance we can consider this the distance is x. As well as we can consider this a projection point is striking the ground. This horizontal distance is called we can say a range. Okay, a range, right? So x equal to, I'm writing ux into t. Then ux equal to, ux is what here? U cos theta into t. Okay, so from this equation, t equal to, I'm writing x by u cos theta. So equation number 1. This, so we got now horizontal component. Okay, we got horizontal component. Then vertical component. Vertical component. So what is how we can find vertical component? Vertical component we need to find. So vertical component uy equal to u sin theta, u sin theta, as well as g acceleration due to gravity is minus g, right? Then we can write vertical component what we are taking y, right? So y equal to, you can write the displacement vector. So y equal to u y into t plus half into gt square. This is a g vertical component, right? So then we can write y equal to uy is how much better here? U sin theta into t minus half into gt square. Okay. So then we can write v equal to y equal to u sin theta, and from the equation 1, what we can write here? X by u cos theta minus half into g into, so again what we can write here? X by u cos theta whole square. U cos theta whole square. Right? So now tell me here y equal to u is get cancelled, then we get it sin theta by cos theta is what? Tan theta. What is that? Tan theta into x minus half into g into x square by u square cos square theta. Okay. So then v equal to, finally we can write tan theta into x minus g by 2u square cos square theta into x square into x square. Okay. So this is the, this equation is called what we can say trajectory equations. Okay. So the assume this is a tan theta equal to, we can consider a. Okay. And this is a g by this term, g by 2u square cos square theta we can consider like a b. Okay. Then you can write it y equal to ax minus bx square. Okay. This equation, it will shows the parabolic path. So finally, we can give the conclusion by using this equation. The path of the projectile is parabola. Okay. So means when a body we are projecting other than the 90 degrees, the path is must be in parabolic path. Okay. So what is the conclusion? What is the conclusion? This equation will give the path of the projectile is path of the projectile is parabolic path. And this equation is called what we can say? Trajectory equation. What is the equation? Trajectory. What is the trajectory, sir? The path of the projectile is called what we can say? Trajectory. Path of the projectile is called we can say? Trajectory. I hope it is clear. Okay. Right. So this is the uh, path of the projectile is a parabolic we proved. Right. Next one we can discuss time of flight. Time of flight. Time of flight. What is the time of flight? Flight means what? Flying in air only. So how much time is there in a air? That is simple. We can call the time taken is for what we can say time of flight. Right? So here time of flight generally and drawing the diagram. Okay. The body is projected from projection point to striking the ground. It is a traveling with the initial velocity u at a maximum height Vy is 0, but horizontal component is must be is there, that is a cos theta. U cos theta. It will be U cos theta. Okay, right. So this is the maximum height. Okay, so here we need to remember one point here: time of ascent and time of descent. So time of ascent means projection point to reaching the maximum height. So I'm writing here time taken to reach the maximum height. Maximum from projection point. Projection point is called time of ascent. Okay. So there is a time of ascent is equal to, we can write u sine theta by g. Same thing here, time of descent also from maximum height to maximum height to reaches the ground. Maximum height to striking the ground. Striking the ground. Time taken is called time of descent. ठीक है? Right. This is a time of descent equal to, we can write that is a u sine theta by g. Then time of flight is what? Time of flight is time of flight. The total time taken from projection point to striking the ground. Okay. So that is the time of flight equal to, we can write time of ascent plus time of descent. Okay. That is we can write u sine theta by g plus u sine theta by g. Then we will get that is 2u sine theta by g. Okay. So this is the time of flight. So this is the one method. So if you know the time of ascent, time of descent, that we can find, that is the, we can solve the equation and we will get the equation is 2u sine theta by g. Okay. But another method we can take here from the kinematic second equation. From the kinematic second equation. Okay. So here projection point to striking the ground. What is the displacement? Displacement is 0, right? And vertical component uy equal to u sine theta, and gravity is minus g. Okay, then we can find here by using the second equation, sy equal to u sine theta into t minus half into g into t square, right? So this displacement is of how much here? 0. Then equal to u sine theta into t minus half gt square, right? Half gt square. Okay. Then from this equation, you can send this a u sine theta into t left hand side minus equal to minus half gt square. So minus minus is a get cancelled, and here one t and here one t is get cancelled. Then the multiply it. 2 will come the left hand side like this. So we can write 2u sine theta equal to gt. Okay, right? So from this equation, we want the t. T equal to what we can write here? 2u sine theta by g. Okay, this is what? Time of flight. So time of flight, we can represent the capital T, right? The time of flight is equation t equal to 2u sine theta by g. This is the time of flight. So time of flight means what? It is the time taken from projection point to striking the ground. The time taken is called what we can say time of flight. During the time of flight, some of the point we need to remember. During the time of flight, we need to remember. Okay, so what are the first point? During time of flight. Okay, so first point, vertical component or vertical displacement. Vertical displacement. Okay, vertical displacement is 0, right? And generally, one second point we can write change in momentum. Change in momentum, the magnitude we can write it is 2mu sine theta. Okay, right? This is the some more point we need to remember, like the angle between velocity and acceleration the during the fall of projectile. That angle is the we can write here one more point we can write it. Rise of projectile, rise of projectile angle is from which angle to which angle here? The 180 degrees to 90 degrees. And next one, falling, fall of projectile. Fall of projectile angle is how much? Angle is 0 to 90 degrees, right? So this is the some point we need to remember during the time of flight. What are the components is changes, okay, right? So this is about the time of flight. Next one, we can discuss the maximum height. Next point, maximum height. Okay. So what is the maximum height? You can take the same diagram. Okay. Where the final velocity will become zero, that is the vertical component velocity will become zero, that the perpendicular distance from the x-axis means horizontal projection. So this distance is called, we can say, maximum height. And we have initial velocity, that is a u. The u can be divided into, you know very well, just now we discussed that the horizontal component and vertical component resolve u cos theta and u sin theta. And angle is theta, means other than 90 degrees, right? So from this equation, we need to find the maximum height. So how we can find? Okay, so here initial value means maximum height means which component here? Perpendicular component means is the vertical component we need to consider. So vertical component, we have initial velocity and we have final velocity. At the projection point, what is the initial velocity vertical component? U sin theta, right? We are considering always the projection point velocity only, right? So uy equal to u sin theta, and acceleration due to gravity vertical component is minus g. Okay, vertical component velocity is a minus, vertical component is uh, vertical component is a minus g. Okay, then what is required more? Maximum displacement h s equal to h max, and then next one, at the highest point vertical component velocity will be zero. Okay, so by using these parameters, we can write the equation. Which equation we can write here? Kinematic third equation. V square minus u square equal to 2as. We are considering all vertical component means y-axis. Okay. Then Vy square is how much here? 0 square minus uy square equal to 2 into gravity is a minus g and s is what? H maximum. Okay, then here minus uy square vertical component velocity what are? U sin theta whole square equal to minus 2g h max. Okay, h max. Okay, sorry for the disturbance. Right, I'm writing here. So then here minus minus is get cancelled, right? Then we can write here u square sin square theta equal to 2g h max. Okay, h max. Then from equation h max equal to, we can add 2g, you can send this side, that is a u square sin square theta by 2g. Okay, so now this is h maximum, at which angle it will be maximum. Okay, right, at which angle it will be maximum? Can you tell me, anyone? Yes, that is the theta equal to 90 degrees. Theta equal to 90 degrees. We can substitute in this equation. Then we will get h max equal to the maximum height formula is u square by 2g. Okay. So means at a 90 degrees, height is a maximum. Okay. Right. In this maximum height, we need to read the, remember the some point. Okay. So some point we need to remember. What is some point we need to remember? First one, vertical component. Vertical component of velocity. vertical component velocity becomes 0. Okay. Then next one, uh, horizontal component. Horizontal component velocity at a highest point means at a maximum height. Highest point is equal to u cos theta. Okay. So this is the point you need to remember. Okay. So this is about maximum height. Okay. So then next one more parameter, that is the range. Next one, range. Range means what? Greatest horizontal distance. Mean from projection point to striking the ground, that horizontal displacement is called what we can say range. Okay. So same diagram I'm drawing here. Same diagram. So this is a projection point to striking the ground. So projection point to O you can take, and the striking the ground. The OA displacement, horizontal displacement, that is called what we can say range. And this one is what? Vertical component is what? H max. And projected with how much angle? Theta. And we have initial velocity how much? Initial velocity is U. This is a Y component, X component. Right? Okay. So this range means is the horizontal distance we need to consider. Then means horizontal component we need to find. Okay, what is the horizontal component equation? We know the second equation. We need to find the displacement vector. We can use which equation? Kinematic second equation. That is the horizontal component. That is x equal to, we can add ux into t plus half into gt square. Already we discussed the horizontal acceleration will be 0. And horizontal velocity is u cos theta. Right? Then what we can write here? Horizontal, this is a horizontal distance. We can write x equal to r. Okay. The greatest horizontal distance is what? Range. Okay. The OA equal to r equal to x. ठीक है बेटा. Then r equal to ux into t. This component what will become? It will be 0. Okay. Why? Because gravity will be 0. So then r equal to u cos theta into t. U cos theta into t. This is a range. But here time we know what is the time here from projection point to striking the ground time taken. That is the time of flight. What is the time of flight formula? Time of flight formula? What is time of flight formula? Can anyone? Anyone? Time of flight equal to 2u sine theta by g. Right? Therefore, so then range equal to u cos theta into t, time of flight is 2u sin theta by g. ठीक है? This is the time of flight formula. From this equation, we can write r equal to u into u is what? U square. Then we can write 2 sin theta cos theta. 2 sin theta into cos theta by g we can write. U square 2 sin theta cos theta by g. Then finally we can write u square into 2 sin theta cos theta. You know the mathematics formula, that is a sin 2 theta equal to 2 sin theta cos theta. Okay. So means we can write this formula is sin 2 theta. Sin 2 theta by g. What is the range formula now? What is the range formula? What is the range? U square sine 2 theta by G. Okay. Then here, at which angle maximum means sine 2 theta. Sine 2 theta at which angle it will be maximum? Means 1. Which angle? At a sine 90. 2 into 90 equal to 1. But here 2 theta is there. 2 theta equal to 90 degrees. Then theta equal to how much? 45 degrees. Yes. Theta equal to 45 degrees it will be maximum. We can substitute in this equation. Then R equal to U square sine 45 by, sorry, just a minute. Sine 2 into 45 by G means R equal to U square by G. This is called, we can say what? Maximum range. What is that? Maximum range. Clear? It is clear, beta everyone? Got it? Okay. So these are the maximum height, range, and time of flight and path of the projectile. So some of the application we can discuss. Some of the application we can discuss today. So relation between maximum height and range. Yes. So H max equal to, what is the formula? U square sine square theta by 2g. Right? And same thing, range. Range formula is what? U square sine 2 theta by g. Okay. So we are finding the ratio of these two one. Right? Then we can write it equation number 1 and equation number 2. From equation 1 and 2, we can write H max by range. H max by range, or R max also we can write better. Okay. Then what we will get here? U square sine square theta by 2g into reciprocal. We can write G by U square sine 2 theta. Anything is cancelled here? Yes, U square get cancelled, G is get cancelled. Then from this equation, we can write sine square theta equal to, so sine square theta by, here 2 is a balance, 2, and this is sine 2 theta. I am writing 2 sine theta into cos theta. 2 sine theta into cos theta. Then here 1 sine is a get cancelled. Then sine by cos, what we can write here? 1 by 4 into sine theta by cos theta. Okay. Then we can write it what here? Sine theta by cos theta is what? Tan theta. Tan theta by 4 means H maximum by R max equal to tan theta by 4. Tan theta by 4. So at which angle is the maximum here? Tan theta equal to at a 45 degrees. At a theta equal to 45 degrees, it will be maximum. Then we can write H max by R max equal to U square by, sorry, 1 by 4. Okay. So otherwise we can write H max equal to R max by 4. Otherwise R max equal to what we can write? U square by G means 4 into G. So H max equal to U square by 4G. Right? So this is the relation, and some more applications are there. In next class, we can discuss the related to this one, and some JEE questions and NEET question we can discuss in a part 2. Okay. If you understood and if you got clarity, please subscribe and comment and like. Thank you. Thank you, everyone.